Well, by the looks of it, looks like most people are here, and for once, maybe start on time. Welcome to the fourth BSUG of the year. Going to take a little bit of a hiatus over the summer. Last couple of speakers will be planned for around September, October. So don't worry if you're not getting emails with the next speakers, but what we've got on the books right now is Teresa Rainey, who's coming from EYP Architects and Engineers out of, I think their main office is in New Jersey, and she's going to talk about modeling for to inform early design. So pretty excited about that. And then the other last speaker is going to be Dr. John Zhai out of UC Boulder. Do you know him? He's a distinguished lecturer for ASHRAE, so we're going to do a combined ASHRAE BSUG presentation. Haven't decided. He has a whole bunch of things he can talk about, kind of just narrowing down on which of those cool topics he's going to talk about. Might be focusing on some natural ventilation, particularly modeling natural ventilation, because that is a real remains a real challenge. But today we're delighted to have Taylor Roberts, who's here from Group 14, and you're in Denver proper, right?
Yes.
And Taylor did his bachelor's in architectural engineering at UC Boulder. He has been with Group 14 for 4 years and does all modeling all the time. So I'm sure he'll have lots of tips and tricks. And so many, we're finding that with the new LEED V4, more and more people are trying to get the points and trying to maximize what they can do. And there still remains a lot of questions about how to achieve that. And since we in the lab are OpenStudio and Energy Plus fans, it's seemed apropos to have you here talking about OpenStudio. And I don't know if you have any experience with eQuest and modeling and that, but if you do, there might be questions about that, because I know there are still people using that. But we're trying slowly to get people to move over to OpenStudio anyway. If they don't want to do Energy Plus, OpenStudio is getting better and better all the time. So without further ado, welcome, and the floor is yours.
Great. Can you hear me? Perfect. Yeah, so this presentation is a presentation I did for a BIPSA, so really getting in kind of the nitty-gritty for energy modelers and practitioners. I also added a little bit that's more high level, kind of some general themes we've been seeing for version 4, so that should apply hopefully to everyone who's doing anything sustainability related. And yeah, I work for Group 14. We're a small consulting firm in Denver, do energy efficiency and sustainability consulting. So we have energy modelers, LEED consultants, commissioning agents, and then we do a lot of existing building work with affordable housing and also retro commissioning. Hopefully the clicker works. Oh, it's not turned on. There we go. I just turned it on though.
Yeah, well, it shouldn't matter.
I can click.
You can do that. This also has a pointer though, if you ever the pointer works. Oh.
Here it is. Okay, great. Yeah, so overview, looking at kind of that higher level first, the LEED version 4 credits, what's changed since version 3, and then kind of our high level takeaway from some of the projects we've worked on so far. Then I'll get into some interpretation, I guess, issues or things that aren't very clear with 90.1 2010 Appendix G from an energy modeler practitioner point of view. And then I'll dive into OpenStudio. So I'll talk about some things, some hiccups, some best tips and tricks that we've done for applying with Appendix G with OpenStudio, and then also kind of go through some less interesting defaults, but I think that are really important to make sure you're paying attention to if you're using OpenStudio to get right so that it is matching what Appendix G is looking for. So high level overview, right? Version 3 to version 4, we went from 2007 to 2010, Appendix G. What LB&L says that means is about an 18% more efficient baseline. So from a practitioner point of view, you know, we're kind of freaking out a little bit, and developers were definitely freaking out. Okay, I still want to be LEED version 4, but you just lost 18% on your energy model. Or LEED version 4 gold or whatever they're trying to achieve. The main performance enhancements of 2010, controls were the big ones, so a ton of more controls on the electrical side, so automatic daylighting controls, anywhere basically that you have glazing, occupancy sensors and vacancy sensors pretty much in every space type. And then also receptacle controls, so that was a big one, and mandatory receptacle control requirements. 50% of switches in offices need to be controlled by the occupancy sensor. The big one there is who knows how well that actually works, because if you tell people which one's controlled by an occupancy sensor, they're going to get a power strip and plug it into the other one most likely. So, but definitely should, as far as the energy modeling goes, a performance enhancement. Mechanical, not a ton of changes. The big ones were a lot of part load efficiency requirements. So full loads were similar as far as efficiency, but now you have to show that, you know, manufacturers have to have better part load performance and prove that. Also, fan control, if you have 10 horsepower, that was a package single zone, now it has to be VAV. So definitely some improvements that lead to this 18% overall. But version 4 also changed the scale on us, right? So we had to meet 10% mandatory for LEED to even be able to be certified in version 3. Version 4 dropped that to 5% with the understanding that the baseline got better. And now the point scale is shifted, right? So this was the point scale in version 3, and now the point scale in version 4 for energy and atmosphere for the optimized energy performance points. In Denver, like the average building that was pursuing LEED was getting about 36% energy cost savings over the 2007 baseline. If you just take the straight reduction, this 18%, we're looking at 7 points in version 4. So definitely a big challenge moving to version 4 if your developer just wants to build the same building, right, and get the same certification. By the looks of it, it's going to be a big issue, 6 points lost for energy and atmosphere. What we've seen isn't necessarily the case. So, you know, 2 of the large building types that we deal with and that are in the commercial building industry, corn shell office and multifamily, that's what's booming right now in Denver, so we're doing a lot of these. An office building, LB&L actually said should be 24% better with the new baseline. So a huge improvement in that baseline. We actually had a pretty good test case. We had a building with the same team, developer, mechanical, doing essentially the same building, a really large corn shell office with a huge parking garage. They received 7 energy points in version 2009 LEED. And now next door, they're building essentially the same building. So same design, and they want the same LEED certification, which isn't going to happen. But kind of just to compare energy with the exact same design, they're looking at 6 energy points. So not nearly as bad of a reduction as we would think going into it. The big reason for that, and I'll get into this more a little bit later, is as LEED shifted, at least in Denver, our baseline energy code shifted. So we went from 2009 IECC to 2015 IECC. So lucky for developers, a lot of these improvements for the office buildings falls on the tenant, not the developer if they're doing a corn shell type. If they're doing a full fit out, then it would fall on them, but the lighting controls, the occupancy controls, that really falls on the tenant, not the developer. Multifamily kind of didn't get affected by 2010 very much at all. So LB&L with multifamily, it was only a 4% increase in energy efficiency savings over the last version. So with the change in scale, we're really at the same place for multifamily as we were. So pretty interesting. Obviously, don't take this to heart. Every building's different. Otherwise, you know, energy modelers wouldn't have jobs. But this, as a general trend, we've seen it hasn't been as bad as we were first expecting. At least for office and multifamily, different projects, different building types are different. As I mentioned, the big part of that codes improved, right? So now the developer has to be better than they were. That's just part of meeting energy code in Denver. And the 2015 ICC has been adopted, I know, around, I'm not sure what the code is here. And then the real big reason is LED lighting. I mean, code is just still so far behind LED lighting. These big parking garages that these projects have get so much savings. They're doing tenant requirements for reduction in lighting power density because the tenant's going to do it anyways with LED lighting. So everyone's still kind of, I call it like the free LED cake. You know, you're eating it and getting cake too and everything because it doesn't cost any more and you get a bunch of savings. I'm sure that'll change going forward, but right now it's still kind of free energy savings compared to the baseline. So we have seen similar savings and not a huge reduction because of code changes in LED lighting, but the big change is version 4. All the other credits got way harder too, especially materials. So everyone's relying more on energy points now. So we have a harder baseline and everyone wants more energy points. So it is interesting because we have seen, which is great, version 4 having teams really look at investing more in HVAC, envelope, other strategies that might have been too cost prohibitive with them in the past because they just, you know, are looking for a level of LEED. And now they're looking at investing in that because that's the only way they can get there. So I wanted to touch on 2 other of the new LEED points that have to do with energy modeling. It sounds like someone's coming to talk about early design. I actually love this credit, integrative process. It's a new one. Everyone seems to want to do it, and it gets modelers involved really, really early. So it's been fantastic. We're getting involved with teams now because they want this point at early SD, even before SD's concept, and doing these simple block models for them. So it's been fantastic as far as getting us in front of the design team earlier and earlier. What this point is looking at doing is doing just a really rough, simple model, you know, like don't worry about all the details, but get them some massing, some different massing. They're looking at different site conditions, envelope and lighting. Also looking at some interesting things. They want you to look at, you know, your thermostat set points and see how that affects everything. Looking at operational parameters, like if you have, we also work on a lot of medical office buildings. You might have one part of the wing and that's actually what this example is. One part was, you know, needs to operate way later than the other parts. So what does putting that on a different HVAC system do? So the main HVAC system doesn't have to run all the time. So it's been great for teams that actually want to meet the intent of this credit and get the point. Our big thing is if you're looking at this credit, make sure you're involved really early. Don't let the design team give you this sheet that you have to fill out at, you know, DDs or CDs and say, hey, we did this right, because it really is pretty extensive what LEED is looking for this. And finally, renewable energy production also affects modelers. So it changed a lot. Really, it got cut in like half. So a lot less points available for this credit, which I think is kind of a bummer. I think LEED is maybe reflecting some of the costs that have been dropping with PV, but we used to be able to get up to 7 points. Now we can only get 3. The good news in this, though, is you can still double dip, so you can still apply that to your energy efficiency for optimized energy performance. But I just want to bring that up because that's another place where it's harder to get optimized energy and atmosphere points. Awesome. So now that was kind of my high-level overview of what we've seen as a company with working on LEED projects for not just modeling, but also as LEED consultants, and now dive really into the nitty-gritty for modelers. So I hope this is helpful for some people doing energy modeling. The first thing I want to talk about is the new requirement of automatic daylighting controls for the baseline and proposed mandatory requirement in ASHRAE. I won't bore you with reading through everything, but essentially any space that's over 250 square feet needs to be modeled with daylighting in both baseline, and then they should be meeting the mandatory requirements in the design, so you'll need to model it in there as well. Some issues that we've had with this is hopefully the designer shows you where the photocell locations are. Hopefully they show you that before you have to submit your LEED submittal, but that doesn't always happen, and it doesn't always directly translate to the baseline. You might have different window to wall ratios in your baseline, right? If you have to have 40%. So we've had a hard time. Appendix G and the user manual doesn't really give you any help on, hey, where should we be putting this photocell in our zones? So I have here kind of a smattering of photocells in that zone for OpenStudio. I mean, technically, any one of those meets kind of the intent of Appendix G, but you get drastically different results from those. So what we try to do as a best practice is making sure it's in the center of the daylighting zone within the zone. Hopefully also your electrical would draw that, but a lot of times they don't. But you can map it out and try to put that photocell in the center of that for your baseline, and then proposed if they show you where they are, wherever they are in that. There's also kind of some gray stuff around its stepped control ranges. So, you know, ASHRAE gives people options of where they want, how they want that control to happen. 100% in between 50 and 70%, and then less than 35% as the 3 steps. We almost never see stepped daylighting controls anymore. It's kind of for fluorescent fixtures. Everyone doing LED, we see dim to off or dim to 10% in the proposed. But for the baseline, you know, it should be whatever ASHRAE is saying. So we recommend just modeling it as 100%, 50% and off in the baseline. And then if they are doing like a dim to off control in the proposed, there's a little bit of savings associated with that. The big one would be this Illuminance Setpoint. Really pay attention to this. So this is a huge deal. Again, hopefully your designer gives you this information, but a lot of times the stage we're building the model, we don't even have lighting plans. So our rule of thumb is 45-foot candles. That's kind of an industry standard. The reason I bring this up is a really nice measure on the building component library for OpenStudio puts photocells in all of your daylighting zones in the center of the zone, which again, I would adjust that and make sure to look which way that photocell is pointing because it's kind of random when you run that measure. But the other thing is it had 450 set points, I think, or foot candles, excuse me. I think there was like a translation issue or something going on. So just double check. It might have been fixed, but 450 foot candles versus 45 is gonna, well, your daylighting won't turn on unless it's getting glare. And then the final thing to note with this is pay attention to your zones versus spaces, right? Common modeling practice, you put a bunch of spaces into one zone. Those spaces might not have control requirements. They're under 250 square feet, right? But your zone you're looking at, it's 1,000 feet that still won't have control requirements. So that's kind of something, you know, you need to pay attention to. Don't just be looking at your zones, but what the design has and what the spaces are. So along the same lines as this automatic receptacle controls. So pretty much any offices, if anyone's seen it, it's usually they have different colored outlets. So one is controlled by the aux sensor and one isn't. And this is required for all offices. The interpretation issue here is ASHRAE is requiring this, but it's mandatory, so Appendix G doesn't really address it, right? But you're still supposed to model it. Show savings, or not show savings, but it should be modeled in both your models. So it's kind of a question mark of how to do that. Nowhere it directly addresses it. Appendix G, you know, addresses occupancy sensor control, which for most spaces is 10%. But what I don't like about that is, right, plug loads should be not during occupied times, hopefully, right? The whole point of occupancy controlled plug loads is if you have something plugged in to the controller when everyone leaves for work, it should turn off. So our recommendation would be definitely applying these savings in non-peak times and times when the spaces are not occupied. So we like to do a schedule adjustment. One of the studies I found, which seemed like this 10% is about close, was from California, and they were showing about 12.7% savings in plug loads for occupancy control. So since it's kind of left out there, we like to do a 10% reduction in the schedule. Well, sorry, we like to do a reduction in the schedule in non-peak times that results in about a 10% overall energy cost savings in plug loads. Again, this is going to be in both, so it's not crazy important, but it's just one of those things that ASHRAE doesn't tell you what to do. The final wrinkle to this is there's a LEED interpretation on this, so people aren't wanting to do occupancy controlled plug loads. My understanding always with LEED is you had to meet the mandatory requirements of ASHRAE because you were following ASHRAE in your design. Apparently they're changing that. I don't know why, but you don't have to. So you can not model or not have in your design occupancy controlled plug loads, and you'll take a hit. They're showing a 20%, so you have to, in your proposed, you have to have a 20% increase in the schedule or the load on the plug loads. I don't know where they got that 20% number from, but they are allowing you to do that for some reason if you have an owner who is refusing to put in occupancy controlled plug loads. So now I want to move more into OpenStudio and some things just to watch out for in OpenStudio and some recommendations on best practices. This one is we've spent a lot of time on, and it's kind of a pain, but looking at how OpenStudio and Energy Plus models glazing. So there's a couple different ways you can do it. There's the full spectral model, spectral average, and simple window method. Simple window method is really nice. I bet that's what most people use. The idea of simple window method is actually to use it in early design before you know exactly what's happening for the glass selection. You don't have, necessarily glazing layouts or anything like that. And it's super nice to be able to input, right? It wants an assembly values, 3 inputs, the U value, the SHGC, and the VT for the assembly, frame, and glass. So that's super nice too, to be able to put that in your baseline, right? The issue with that is when you're really looking at different glass types, you might have 2 different manufacturers with a glass that the SHGC says it's the same, but they could perform different based on angular dependence of how the sun's hitting that glass. So the full spectral model accounts for that. And it's recommended by this study, in 2010 that ABIPSA put out by Peter Lyons. The issue is OpenStudio doesn't really support this at this time. So how we've been doing it is you can get all the full spectral data you need out of LBNL's Windows program, which is really nice. They pretty much have every manufacturer in there, every type of glass. You get this huge, long, IDF out of it. It'll produce an IDF for you, and it has every point on the glass and how the sun's hitting it and how that affects everything. And what we do is we have a big library of these, right? You have basically all the commonly used commercial glass in there. Every time we have a new one, you can put it in there. And then in SketchUp, you can actually input construction IDFs. So you can bring in the frame IDF, and you can bring in these glass IDFs, which is nice. You can also set, there's a measure that you can put the frames on the glass. So you can set window property frame and divider. So that part's good. The issue is that it wants average spectral, which of the 3 options that research paper actually said was the worst option. You should just use the simple method over the average. So we did have to write a measure to be able to do this that kind of is an Energy Plus measure. All you really need to do, right, is you have a construction and it doesn't grab that spectral reference huge IDF with it. It just has the construction, but an Energy Plus measure, you can say, hey, reference this folder that has all this information in here and grab it and put it in there, and then Energy Plus will run it just fine. Another issue with doing this, but we still recommend it because you have a higher level of consistency and accuracy with your glazing, is then Energy Plus won't give you an assembly U factor or SHGC. It's modeled separately, which in reality is closer. You have a piece of glass, and then you have framing, and then they do have an edge, a glass factor in there. But there's no report nowhere that will tell you what your assembly is in your model. So you have to post-process what your assembly values are. I mean, maybe a nice thing is a LEED reviewer couldn't tell you you're wrong because they couldn't find it anywhere, but it is really annoying. So we do a bunch of post-processing in spreadsheets and Windows program and the window program to figure out what the proposed assembly U factor and SHGC is with our frame widths, and then also what the baseline frame widths should be to get the correct assembly U value. So definitely an extra step, something that'd be amazing if the Energy Plus team could find a way to help us out there and do an assembly value like eQuest did do assemblies. But so a little bit extra step, but then you get a lot more accuracy in your glazing. So moving from glass to HVAC, this one I played with for so long and it drove me crazy. Demand control ventilation, right? Demand control ventilation at a code level, at an ASHRAE level, is per zone. So code wants you in a zone like this to have an CO2 monitoring or a CO2 monitor, and if you need to, code really wants you to increase outside air. From an energy saving perspective, you should also be decreasing outside air if no one's in here, which is great. But from really a design level and definitely an OpenStudio level, that all happens at a system level, not at a zone level, right? I can't tell a VAV box to get more outside air or less outside air. I have to tell the unit. So what can be a huge issue with LEED reviewers looking at your model, they want to know, okay, you have 3 zones that need demand control ventilation, and it's in the proposed, are you modeled the same? Well, your baseline might have 1 VAV serving that floor, and your proposed might have 1 VAV serving the whole building. So if you just turn on demand control ventilation in your proposed, you're technically providing demand control ventilation for the whole building, not just those zones. So it can definitely be an issue of how to actually model that. The best way we found to do this, if you just have certain zones on a larger system that need demand control, is Energy Plus's demand control ventilation is controlled by the occupancy, this occupancy schedule, and then your outside air values per person. So if you have a zone that has a 0 for outdoor airflow per person, that zone will not have demand control. So you can actually back calculate what your flow per area should be for those zones that don't have demand control and just put it in there and 0 out the per person. And then that unit will only provide demand control to the zones with an outdoor airflow per person. So it's kind of a workaround, but then technically you're meeting the intent of 90.1 and 62.1, and you shouldn't get any flack from the LEED reviewer. A side note on this is that if you have like a gym space, the default in OpenStudio is there is no outside airflow per person. It's only a square footage. So that if you have demand control, you're going to have to change that. Otherwise, demand control won't work for that unit serving that zone. So just pay attention to that. But that's the best workaround we found. If someone else knows a better way, I'd love to find that out. The next one that we've had a hard time with is the minimum efficiency requirements with the part load. So for Energy Plus and OpenStudio, you put in a full load, right? I can change that to whatever I want, whatever COP to match whatever EER. But the part load is all based off the curve. So your DX coil curve or your chiller curve is going to inform what that part load ends up being. So what can be hard about that is getting curves from manufacturers, for one, and then also just a bunch of baseline curves. There's just not a lot out there. The Energy Plus data set has a ton of water-cooled chiller curves, which is really nice. So you can use those curves, put them into OpenStudio, and kind of find the correct IPLV that your chiller should have. It is a bigger issue with air-cooled chillers and DX coils. Energy Plus only has really one curve for DX coils, depending on what speed you have, like a 1-speed or a 2-speed. And then air-cooled chillers, they only have like 3 or 4 in this library. So that's something that we're still trying to get more curves to help us meet these IPLVs that we need to meet in the baseline. ASHRAE is working on this. They're trying to standardize curves, so I'm really excited for that project to make it through. But as of now, the best advice I can give you is that use that Energy Plus data set curves to the best of your ability, and try to get as close as you can. So now I kind of want to move to some defaults that Some of these might seem very basic, but I just want to bring it up because they're not defaulted in OpenStudio, and this can change things, and just some good things to kind of go through and make sure everything's right when you're getting ready to submit that final model to USGBC. The first one is if you go in your thermal zone tab, for whatever reason, the defaults in there are kind of random for the cooling temperature and heating temperature. They're like 57 for cooling and 104 for heating. And if Appendix G wants a 20-degree delta T off whatever your set point temperature is, so, you know, common 75 and 70, you would want 55 and 90. So cooling's close, heating's way off. So I'd check that. That's also can be an issue if you have unmet hours, because you might be saying, hey, VAV box size for 105-degree temperature, but I'm only, you know, going to let you go to 90, and then you'll get unmet hours. So I'd look at that too if you have unmet hours. The other ones, obviously, look at your fan power. Make sure that KW in your output reports is that KW that you have in your table 1.4. Same with your cooling and heating efficiencies. Those are all basic. The heat pump, one thing we've noticed is like from the HVAC library in OpenStudio, you grab in some heat pumps. They're operating when they should have the auxiliary heat. It does not reference ASHRAE. It's just kind of random. It's like 18 degrees, which is amazing if you have a really good package terminal heat pump, but most heat pumps don't do that. And ASHRAE actually says 40. So I'd definitely make sure that's in your baseline. And if your proposed has PTHPs and they're better than that, change it. But really the best we've seen is like 32 degrees. So I don't know, the 18 degrees is like fantastic. I don't know where that came from though. Another big one, VAV fan curve. If you're using like the plus button to create systems or just grabbing it from the library again, that does not match ASHRAE Appendix G's VAV fan curve. So you'll want to update that. And finally, night cycling control. This was just a big one. It's pretty simple, but in Energy Plus and OpenStudio, you want your VAV to cycle at night, but you do not want that outside air damper to open. So in the control of the VAV, it's pretty easy to click, you know, hey, cycle on at night, follow this schedule. You want to really make sure, though, that your controller outside air has that same schedule so that outside air damper won't open. That's kind of a thing that we've had issues with in the past. So our best practices for all this stuff, actually, I think I have that in a slide. You'll have to hold on for that. So the other one is plants. So plants, again, if you're using that plus button for ASHRAE System 7 or whatever, none of the controls are right. So definitely be paying attention to all those set point managers and the sizing information. Those won't be correct for your boiler and chiller loops or your condenser loops. The other one, which was a great, this is explained in length on unmet hours, if you're an unmet hours user, is doing the correct control for a chilled water plant. You want primary, secondary for Appendix G. It's not seen very much anymore. You know, variable primary is usually what we see. But for the baseline, it's important to get that right. You can't really model it how you would want to model it in OpenStudio right now, which is a pump on the chiller, right? Like, I just want to put a pump right here and then have a variable speed pump there to do chiller pumps, but you can't do that. So the best workaround that we've seen is doing individual loops for each chiller in your baseline with a constant volume pump on those, and then an ideal heat exchanger, right? That's a mythical perfect heat exchanger onto your secondary loop with variable speed to get those all right and make sure your pump power is right for LEED. Here's the best practices. So the best practices for a lot of these HVAC library things we've seen is that you can actually hack into that. So that's just in the OpenStudio folder structure. You can go get the HVAC library, and we've just added a bunch of, you know, things we want, like a VAV with the appropriate fan curve on it. All the chillers that Energy Plus library has, so I can have a bunch of chillers I can grab and try and get the right IPLV from. So that's definitely a huge recommendation. It saved us a bunch of time to go in there and kind of hack into that and add your own stuff, and then it's always available when you're in the OS app. It is kind of, sometimes it, like your computer doesn't want you to, and you have to like move it and save it and then move it back, but you can, it's doable. We also use a lot of templates, so you can, how OpenStudio used to, 2.5, I don't use like their templates anymore because we have all of our own, but how it used to do it was it's just basically a blank OSM with no thermal zones or spaces that has a bunch of schedules and everything. So you can also access those and kind of make them your own. So we really like doing that and getting all our templates exactly how we want, like for an office or multifamily or hospital, get all that information in there, and then you can save it and use it again for other projects. And then finally, anyone using OpenStudio knows you're going to have to write some code. So we use measures extensively. We've created all our own measures for all the ASHRAE systems that just kind of take what those plus button does in the HVAC tab and expand on it and make it exactly how we want it, make sure all the pump power is correct, all the controls are correct. We really like that approach because it gives us a lot of flexibility on where we're applying those baseline systems in our model. But there is the baseline generator measure that OpenStudio has and Rails worked really hard on. So if you haven't invested time into learning measures or spending time on measures, that could be a really good way to go to. I don't trust all baseline generators. I would definitely check it out after you use it, but it is a good option as well to make sure you're getting the right controls and everything in your model. So finally, the last thing we have is you like a happy lead reviewer, not a sad lead reviewer. So OpenStudio does everything in SI units, all the output report, which I think is great if you work in a university setting, but in industry, no one likes SI units. I'm slowly learning, but it's still hard. So it's definitely nice when you're giving your final submittal, submitting anything to USGBC as far as output reports, convert that to IP units. You don't have to, nowhere says you have to, but we've seen lead reviewers like that, so they're not, Googling meters cubed per second to CFM and everything else. There's actually a measure on the BCL for that works really slick. It'll convert it for you. It will break all of OpenStudio's output reporting stuff, so I do it very last because then, you won't get any of that. Sometimes it says it fails. It didn't fail. It's just OpenStudio trying to make its output reports that failed. We also like to edit that a little bit further. So, you're providing the HTML output report to the reviewer. We found that giving them too much information is almost as bad as giving them not enough information. So getting rid of all the reports they don't ask for because we get random extraneous comments that really don't have anything to do with anything. A lot of times because Energy Plus still isn't used a lot for lead submittals and they're not used to looking at those output reports. So you can edit that table really easily as well, the object for Energy Plus, and get in there just the information you want for the reviewer, and then they get a nice packaged output report instead of OpenStudio's generic, thousands of pages long and in the wrong units. So that really covers a lot of what we've learned as we've been moving to version 4 and as we've just been using OpenStudio a lot for lead submittals. I think it's been really great. There's been a lot of complaints about version 4, mostly from the developer side and people paying for it, which I understand. But I really do think Appendix G or ASHRAE 2010 is pushing buildings to be more efficient. And LEED version 4 is even pushing harder and making people really invest more that we've seen in high performance HVAC and envelope beyond just lighting. But the key to all this, right, is that as practitioners, or if you're doing a version 4 project, you have to provide the owner with accurate and correct information as far as to the best of our abilities, which is referencing ASHRAE and Appendix G. So hopefully you learned a few good tricks and tips and hopefully some takeaways. And if you have any better ones, please let me know because we would love to learn those as well. So thanks, everybody.
So I've been using OpenStudio for a year and a half or something. Haven't gotten into measure writing. How do you recommend getting started with writing measures?
So a couple things. I did it just by reading the measure writing guide, which is a good place to start, but it is very, very not complete. And you'll find out quickly that you know, I just did a bunch of guessing and checking and finally got there, and then you kind of get the deal. I would recommend, not to, I guess, kind of a shameless plug, but there are companies that do measure writing specific trainings. I've done one of those. I thought it was very useful. A lot of my colleagues did it. I think it can be helpful. And if you want more information on that, I could give that to you. But that's available. If not, just take some Ruby classes online. They're free. And read the measure guide. It'll take you a little bit. And then copy everyone else's that are free online and adjust them. And you'll get pretty far.
Yeah, pretty much. Yeah, I would say also just like reading a bunch of measure code. Like I think the NREL BCL measures are available. Like they're open now on GitHub, so you can go and look at the existing measure code, and that's helped a lot. And then for people on GitHub to go through, like maybe look for a specific method, you can search for that and see how it's used, how it fixes the other one.
Yeah,
that helps out a lot.
That's very helpful. And then the other thing too is it is Ruby, right? It's not some random language that they developed. So you can Google, if your issue is Ruby specific, there is so much information online for free on Ruby. You can say, I want to do this in Ruby, and you'll get 500 threads that tell you how to do that 500 different ways.
I just have a question. It's a very specific question.
Yeah.
Have you had success or have you tried modeling DOAS systems in OpenStudio?
Yes.
And how is that?
And yes. Hard size, hard size, hard size. So any air loop is going to want to auto size to meet all the loads in a zone. So to do a DOAS, you always need to be hard sizing all the flows so that it doesn't do that. Otherwise, yeah, you'll get crazy. You know, you'll have a DOAS to a 4-pipe or whatever, and it will try to meet all those loads without the 4-pipe. That's just kind of how the Energy Plus works. And then the other advice that I really give all the time for everything would be when you're doing something new, and now version 2.5 or 2.0 really and beyond makes this a lot easier. Do a ton of hourly reports. Get hourly reports on a bunch of nodes and check them out and make sure it's doing what you want it to do. Sometimes it doesn't, it's really frustrating, but then at least you know why, or at least you know it's doing it. Fixing it sometimes is an issue, but yeah, my first thing with DOAS would be hard size everything and then run some hourly reports and make sure it's doing it.
Just had an online question here about the glazing systems. So how do you choose your baseline glazing with full spectrum approach?
It's a great question. So we used to do this also in eQuest, which is similarly convoluted but a little easier. So for Appendix G, depending on your frame width, cardinal 272 with a 6mm piece of glass and then an air gap and a 3mm piece of glass is about as close as we've gotten to getting the correct SHGC values and U value for the baseline. But again, the U value is going to be affected by your frame width and your frame construction. But that's what we use. ICC throws a wrench in all that because then the U value is different. But it's kind of guess and check and get as close as you can, but that's been the glass we use.
Any other online questions?
So is there any reason that you switch from eQuest to Energy Plus OpenStudio?
Yeah, we switched because we do an incentive-based program in Denver for the utility, which requires the use of OpenStudio. So we kind of got forced into switching. I was a proponent of switching before that, so that kind of made me happy, but not everyone at our office happy or in Denver. So yeah, we were forced to, but now we use it for everything because we've built everything, but it's definitely it's way more flexible than eQuest. I love from an engineering background. I love being able to write code and mess with it and make it do what I want it to do. But it's way more time intensive up front to get going on it than it is for eQuest.
And a last question from someone that used to be at our lab, Chinmay. Any guidelines on how to model heat recovery chiller?
Ooh, I have never modeled a heat recovery chiller, but I would start with unmet hours and read what other people have done. I know it's difficult. I have done water-to-water heat pumps, which would be kind of similar. That object kind of scares me though, because it's all curve-based. If you don't have good curves, who knows what's happening. So I think that's one option, but there's a bunch of options I know on unmet hours, all of them probably difficult.
Cool, thank you.
Any other questions from the room? I know that there's probably a lot of very specific questions that each one of you could ask about specific modeling problems. I'm sure that Taylor might be able to attempt to answer a few of those here. But if there aren't any more questions, I've got a couple of the door prizes today, and I don't know, the ones I picked do not have names on them, so you'll have to look at hopefully you kept your ticket stub, because I have got ticket number 6980056. All right, and then I've got 6980059. There we go. And yay!